Okay. Okay. So now we are a little bit familiar with the quadratic function, no? Because we are solving quadratic equations, but we analyze like a functions. So basically, we have two kinds of quadratic function, two different forms to represent quadratic function. The first one is the standard. Es standard, es the classic standard form, que es the classic, for example, f of x equal ax squared plus bx plus c. But actually, in the chapter 1, when we are solving this quadratic equation by quadratic formula or by factorization, okay, the thing okay, we are doing is find the x-intercept of the quadratic formula, because remember the mnemonic device to remember the idea for the x-intercept is you put the f of x equal to 0. So actually, I want to discuss in detail this. Don't worry, I explain more clear after that. Okay, this is one way. Okay, super. And another way is the vertex form, que es f of x equal a paréntesis x minus h square plus k. Advantage and disadvantage. Well, this is, some people prefer standard because I'm familiar with this. But vertex is super important because talking about vertex, and the vertex is the most important point in the parabola. You know, the parabola look like that, boom, right? Open up or open down. I'm discussing in detail now in what direction open. At this point, or this point, depending if open up or open down, it's the vertex. It's the turning point. So this is a super important point in the parabola. The vertex is always h, comma k. Who is h? Who is k? Look at that. This is h, and this is k. Okay, in the standard, you don't see h and k. You see a, b, c only. But it's okay. It's okay. Let's see the most important idea. And why not? What is the way to conversion from a standard to vertex or vertex to a standard? Because sometimes in the problem, give me the equation in vertex form. Okay. And sometimes the majority of the case give me a standard. I need to know how we convert from one to one, no? Okay. So now wait, before this, let's do in the conversion. Let's do in the conversion, and not necessarily you are doing this anytime can you try to convert from this to this or this to that. Only you apply the formula and that's it. It's super easy. Yeah, I want to explain the shortcut, but I want to prove for you, right? Okay, suppose now I start for the standard. I replace f of x for y. You know, it's equivalent, no? Function notation, no function notation. Okay. Oof. Undo. X squared plus bx plus c. So in order to manipulate this equation and express it approximately or equal to this expression, I propose you complete the square. But to complete the square, you need that the coefficient in front of the quadratic should be 1. So you divide by a everything, y over a is equal x squared, because a is cancelled, no? Plus b divided by ax plus, you put c over a, but no, because I want to complete the square with the magic number. Remember the magic number is you divide b. In this case, this is b, actually. So the b divided by 2. Okay, actually it's b divided by 2. It's no b, it's the coefficient from the x, the linear, and square. So it's b squared divided by 4a squared. And this is the magic number, b squared over 4a squared. Plus c over a, get the original, look, this guy, I bring, and subtracting b squared minus 4a squared, because remember I put totally artificially this coefficient in order to complete the square. Now I can see that this part is a perfect square trinomial, and the factorization is x plus square root this guy is b over 2a squared. Bam. Plus well, and that part, I propose you, for example, find the least common denominator, get 4a squared. So we have 4a squared divided by a is 4a times c is 4ac minus b squared. Boom. And finally, remember this is equal y divided by a. You multiply again, because I want to isolate the y. Okay, by the way, y and f of x is equivalent. You multiply everything by a here, by a here, and by a here. So it's equal a x plus b over 2a squared plus 4ac minus b squared divided by 4a. Because at least this a is canceled out with one, only one. Okay, entonces now I compare. Remember, I start with the standard. I manipulate using complete square. And I get one que is similar to the vertex 4. Look at that. Let me copy the vertex 4. It's fine here. Sorry. F minus h squared plus k equal y or f of x, either way. So I conclude. Compare this and this. This guy, boom, 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 is h is equal minus b over 2a. Because minus h is equal to that. Okay, is 4ac minus b squared over 4a. Okay, and this is our formula. You don't worry, the most important formula today is this. Because one super easy way to find k is just plugging in. And when you have k in your hand, you plug it in. Look, suppose this is super easy formula. Minus b over 2a. No, easy. However, if you want to find the k, I never memorize this stupid formula. No. Because the only super fantastic way is evaluate f and h. So plugging in h here, and you get k. Boom. This is easy to remember. And the function in the example, the typical example we're doing, you evaluate h. H is this formula, easy to remember, and evaluate k. Don't end the story. Okay. So you don't need to memorize complete square. No. Using the formula is much better, more fast, in my opinion. And the most important thing in the quadratic function is number one. The most important characteristic is number one. Is a vertex. A vertex is a point h, k. See, the problem give me the equation in vertex form is super easy. It's h and k. I can see. No computation. See, the formula is given in standard. Well, no problem. I using that formula. So I compute h first. Is h minus b over 2a. By the way, guys, this will look like, remember the quadratic formula to find the quadratic equation, this minus b plus or minus the square root b squared minus 4ac divided by 2a, no? That part is exactly the formula for the h. Entonces, in order to find the k, well, you plug it in the function h. Boom, that's it. It's the only formula you need. Okay, you will find the vertex. Number 2 is in what direction? Open the parabola. And this is controlled for A. Coefficient A is super important. And the coefficient in front of the quadratic. Si A is positive, the parabola open up. And by the way, this is the vertex H, comma K, no? Si the A is negative, the parabola open down. And again, the vertex is this or this. Okay, the control in what direction open is given by A, the sign of A positive, A negative. You see, I promise you see several examples. We are doing the graph. We see in decimals, everything clear. Okay, what is the next step? What is the next step? Well, the next step is number 3. You find y in a set and x in a set. Okay, remember y in a set is the point in which the parabola crosses the y-axis. And x in a set is the point in which the parabola crosses the x-axis. Okay, okay. So what is the formula for finding y in a set and x in a set? Well, always the formula is for y in a set, evaluate 0. This is general, but particular for the quadratic function. Look, suppose this is advantage and disadvantage. Suppose I have the standard like that. When you evaluate 0, that part disappear, 0, that part disappear. Therefore, the answer is C. This is the advantage of the standard. The standard you see the coefficient C is the y in the set. And in the vertex form, no, it's not clear. It's a little bit confusing. No, but no, it's easy. You plug it, you put equal, you plug in 0, x equals 0, and determine the y value associated with this. It's no big deal, but in this case, super easy. It's just see as the interpretation for the parabola is a y. However, the x in S is always complicated because as f of x equals 0. This is the formula, no? That allow us to find the x in S in any function, not necessarily in quadratic function. However, well, that problem is equivalent to that problem is ax squared plus bx plus c equal to 0. Wow, this is the thing that we are doing before. It's a solution for the quadratic equation. So when you solving the quadratic equation, actually the thing that we are doing is determine the x-intercept of the parabola. Okay, or in other words, the point in which the parabola crosses the x-axis. Well, that's okay. I understand. However, we have 3 possibilities. Look at that. We have 3 possibilities. Let me use another color. We have the possibility in which the parabola crosses the x-axis in 2 points. Entonces, this is the most common case, que the solution for this equation contains 2 solutions. Because cross it, the x-axis in 2, so 2 solutions. But not always happen. We have, for example, one solution in which exactly they are perfect coincidence, que the vertex lie on the x-axis. One solution. And another possibility, que es the last one, is que never. Suppose que the parabola doing like that. That is under the supposition that the parabola open up. But if the parabola open down, it's the same. So here is a complex solution. And you know, complex solution, you don't see in this plane because complex solution living in another dimension. O sea, it's impossible to see. And this is classical. When you in algebra try to find something, in this case, x-intercept, and you get a complex solution or imaginary solution, by the way, is the same. The interpretation is the thing that you try to looking for do not exist. In this case, do not exist what? Do not exist the x-intercept because the parabola never crossed the x-axis. Entonces, how? What is the formula? Que help me to find out. Well, you can use the quadratic formula, but no, much better, more quickly, faster is you using the expression inside the quadratic formula. So the famous expression que is the first thing you should do is b squared. B squared, you compute d, discriminant. Wow, it's the arrow. Why is the arrow? No arrow. Delete that. With the arrow, d is b squared minus 4ac. Entonces, when the d is discriminant, is positive. We have two solutions. Because, well, it's logical, no? Because you find the solution, you apply square root, and you put plus and minus, and this plus and minus is the idea that allows us to have two solutions. However, si discriminant is 0, no, that part disappears, in the quadratic formula, and we have only one solution. And you see before, of course, when the d is negative, is imaginary, that part, and well, combined with the other part is a complex. Entonces, that is the reason que do not exist. Okay? So remember, when you find the x-intercept, you solve the quadratic equation. Depending the discriminant, we have three possibilities. To intersect one or no intersect. That's it. No, we have more information. We have a super important information, que is the axis of symmetry. So it's easy to understand. Look, axis of symmetry. Number 4. I need black. Number 4. Number 4 is the axis of symmetry. What is that? Well, this is easy. This is, you know, except you have the parabola. Suppose we have the parabola. Like that, like that. Open up, open down. And the axis of symmetry always is a vertical line passing through the vertex. No good. Blue. Is the vertical line passing through the vertex. Okay, remember the vertex is a famous point, h, k. This again is h, k. The only difference between this parabola is that this parabola A is positive and this is A is negative. But what is important? What is important, the axis of symmetry? Oh, because maybe sometimes the example you see, we have different points. And you can find the image of this point and the other branch of the parabola because this distance is the same, symmetry. Distance. And so you obtain this point using the symmetry property. And to see, I ask you, well, okay, what's the equation? What is the equation of the axis of symmetry? What is the equation of the axis of symmetry? Well, it's a vertical line. And a vertical line is x equals something. And something what? The x component of the vertex is h. Boom. This is the equation of the axis of symmetry. Okay, and this is a quick tours to the most important property of the quadratic function in two versions, in standard and vertex form. Well, let's do an example, no? I bring a very illustrative, nice example. Little by little, we discuss and detail everything. Any question? Any question? Quadratic function and their application. I'll see after the application. Okay. Delete. Wow. What's going on? Okay, good. Okay, example one. Example one. Example one. Example one say f of x equal minus 2 parentheses x minus 1 squared plus 8. Entonces, what is the question? The question say, well, okay. Do the graph of the parabola. Do the graph. Is the question. At least in this mode. So I present to you different parabolas and to say you, first of all, identification, if the question is given in the example, corresponding with the vertex 4 or standard. Number one. Number two, determine the parameter A, B, C or A, H, K. And the rest is determine the vertex, determine in what direction open the parabola, and determine the famous point X and Z, Y, and Z, and using your common sense to using the symmetry property, determine one more point and do the graph. Okay? The question one is this parabola or this quadratic function, the synonym, you know, is expressed in vertex form or standard? Answer me. Answer me. Are you sleeping?
That's vertex form.
Exactly. We compare mentally with the another way is y equal a x minus h squared plus k. Something like that. Entonces now, this vertex. This vertex form. Who is A, who is H, and who is K? Be careful with the sign. Who is A? Who is A? Who is A?
A
Who
is
A?
-2.
A and -2. Very well. Who is H?
-1.
No, +1. Look, Yasmin. When you see the sign is the same, it's because H is 1, right? Makes sense or not?
Yeah.
It's tricky, I know. H.
And K is 8.
Absolutely. So now, I ask you, in what direction open that parabola? In what direction open? Upward or downward? In what direction open this parabola? Who is the parameter that give me the control? In what direction open? Nobody know? Hey, it's important.
I believe it's a positive parabola.
But in what direction open? You have two possibilities. Up. She said up. Everyone is agreeing with David? Okay, David, why up? What is the parameter that have the control in what direction open? Hey, is the parameter that have the control. Look, this number is negative. If it's negative, it's down. Okay?
Oh, I'm sorry. It's a negative parabola. I apologize.
Bueno, es no negative parábola. Es de parábola que open down. And open down because A is negative. Okay, A is negative 2 equal negative 2. Therefore, the parabola open down. Ah, by the way, that point is the vertex. And the vertex is located at the point something comma something. H comma K, 1 comma A. Correct? Correct?
Yes. So it's
Super.
A determines if the parabola is positive or negative.
A control the direction of open the parabola. Si A is negative down, si A is positive up. Okay? What more information? Well, wait, I need extra point. Suppose I need to find Y in the set. Well, unfortunately, our equation is expressed in vertex form, thus it's not clear. In the standard was super clear because C, the Y in the set. But okay, I know the formula, que es evaluated 0. Entonces, Y value is equal negative 2, parenthesis 0 minus 1 square plus 8. Now you replace plugging in 0 here and X. And compute that. Y is equal 0 minus 1 is negative 1 square is positive, so it's minus 2 plus 8 is 6. Therefore, the famous Y in a set is at the point 0, 6. Because the supposition and the formula is que X is 0. Because on the Y-axis, any component X is 0. Okay, super. Now, the X in a set is similar, is f of x equals 0. And f of x equals 0, well, you take this equation that's given at the beginning, negative 2 parenthesis x minus 1 squared plus 8 equals 0. And you solving this equation. Not necessarily expand and apply quadratic formula. No, because I take advantage. If somebody do the factorization here, x minus 1 squared, and you apply a square root principle, square root method. So in the square root method, for example, I move 8 to the other side, divided by negative to both sides. That's x minus 1 squared equal 4. Nice, I like that. Apply square root both sides. Remember, square root method. Square root both sides. So x minus 1 without square and square root is equal, and square root 4 is 2, but plus or minus. Now finally, so for x is 1 plus or minus 2. No? I move this negative 1 to the other side of the positive 1. So 1 plus 2 is 3. And 1 minus 2 is negative 1. So I discovered that actually we have 2 x in a set. We have 2. Okay, that is the point 3, 0 and negative 1, 0. Remember the supposition at the beginning was that the y value is 0. This is clear, guys? Okay, let me try now to do roughly sketch by hand of the barrel. At least in this part, I want to do roughly sketch. After, you can see in this more clear. Suppose this is my rectangular coordinate system. Okay, what information I have in my hand? Well, I have in my hand vertex. It's the most important point. Wow, it's 1,8. 1,8. Unfortunately, A is a little bit out the rectangular, my small rectangular coordinate system, but no, I try to do my best. This is 7, this is 8, and 1. I suppose that the vertex 1,8 is look at it. 1 in the x component, 8 in the y component. This is y-axis, extension of the y-axis. Done. Boom, I plot that. 0.6 on the y-axis here, over there. Bang. One more point, this and this. 3.0 and negative 1.0. Okay, entonces I suppose, using my imagination, que de parábola, bueno, using my imagination, no. I know que the parabola up and down. So the parabola look like that. Boom, boom, boom. However, using the idea of the axis of symmetry, look, I know that the axis of symmetry is a line, vertical line passing through the vertex. And the distance between, for example, I can suppose perfectly, not complicated, that we have one extra point here, right? Using the symmetry. This point was 0.6. It was the y-intercept. And this point would be 2.6 because the component is the same distance from the axial symmetry and the same y component is 6. Okay, nice. So we have 5 points. 5 points is good to have some idea how it look like our parabola. Let me try to do my best by hand. However, after using decimals, look. Okay. Okay, passing through negative 1. No good, my case. Okay, it's important to understand that the parabola never is like that. Boom, boom. This is not parabola. This sharper point is not. Parabola is a smooth curve. And this is a little bit rounded, right? Okay, I did a mess. Therefore, I want to go to decimals to see much better. Okay, I highly recommend in the test you are doing every graph using decimals, which is our famous graphical way. Okay, let me try. Here, over there, here. Share the screen. Decimals. Switching to decimals. Do you see decimals now? Answer me. Do you see or no?
Yes.
Yeah.
Okay. Okay,
Yes,
this is my
yes.
This is my first example. Boom. Look at that. Okay, this is my parabola. My parabola up and down because A is negative. The vertex is located at the point 1,8. Nice. Look at that. The y-intercept is the point 0,6. And this is the additional point we obtain using the symmetry idea. Okay, the same distance as 1, 1 in opposite direction. With respect to the axial symmetry, of course, and the two famous x-intercept, negative 1,0, 3,0. Wow, fantastic. Okay. And remember in the test, you click here and here. Yeah. And you export like an image and you attach in your test. Okay. Good. Super good. I like that. Very well. Any question in example 1? Any question in example 1? Let's move on to example 2 now. I suppose you see whiteboard now? Well, the only disadvantage I saw in this new whiteboard is that I cannot erase everything in one click. I need to select and I delete. Come on. Okay. Example 3. Example 2, sorry. 2. Example 2 now. Okay, example 2 is f of x is equal 3 x squared plus 12 x plus 5. Here we are doing the same. Do the graph. Do the graph. Okay, number one step is identification if this equation is given is expressed in standard or vertex form. What do you think? What do you think? Standard or vertex form? Opinion. We have two possibilities. Standard. Absolutely. I see it's a standard because mentally you compare with ax squared plus bx plus c, ¿no? Entonces es obvio que a es 3, b es 12, and c es 5. Super good. Perfect. Now, I ask you, in what direction open this parabola? Up or down? This is important information. Direction in which open the parabola. In what direction open? Open up? Open up. How do you know que open up? What is the clue que give me information? Open up.
A is positive.
Excellent. Because A is positive, get 3. Super. Now, the next important in order to importance is the vertex. The famous H, K point. But unfortunately, we have no H and K because my example is expressed in standard. But don't worry, be happy because you know the relationship. What are the formulas? The formula is H is equal minus B over 2. And the formula for K, well, I derivate at the beginning, but no, it's easy without. You evaluate the function in H after, and you will take it. Okay, in our specific example, H is equal minus B is 12 and A is 3, 2 times 3. Entonces es obvio que es 2 times 3 is 6, 12 divided by 6 is 2 is negative. H is negative. And K, well, you evaluate F and negative 2. And when you evaluate F and negative 2, we have 3, negative 2 squared, plus 12 times negative 2 plus 5. Okay, negative 2 squared positive 4, and positive 4 times 3 is positive 12. Minus, because 12 times negative 2 is negative 24 plus 5. Entonces 12 minus 24 is negative 12. Plus 5 is negative 7. Conclusion. Our vertex is located at the point negative 2, negative 5. Okay. It's in the third quadrant, but it's okay. And the parabola open.
Negative 7.
Negative 7. Negative 7. You are right. Negative 7. Okay, entonces ahí. No, negative 7. Okay, super. Thank you. What more information we need? We need in a set. Y in a set, X in a set. Okay, but this is super easy because, for example, Y in a set, I take a shortcut. I know that always is equal C. And C in our example 5. This is the advantage of the standard. You see that Y in a set is C, 0,C. In our specific example, it's 0,5. It's 0,5. And the X in a set always is a little bit more complicated. You apply the quadratic formula for finding the intercept. And that's it. Let's try. Is f of x equal to 0. In other words, is 3x squared plus 12x plus 5 equal to 0. So you solve in this equation. This is nothing for us. In the chapter 1, we are doing a lot of formulas of the quadratic equation. Entonces, minus b plus minus square root b squared minus 4ac divided by 12. In our specific example is minus 12 plus or minus square root 12 squared minus 4 multiplication by 3 multiplication by 5. Divided by 2 times 1, 2 times 3, sorry. Okay, super. Well, okay, as always, we focusing on the expression inside the rat. This one. And we compute 12 squared 144 minus something, minus 60, because 4 times 3 is 12 times 5 is 60. And you subtracting is 84, 84, 84. And the square root 84 is well, it's something. So you can suppose 84, you break it down, 242, 221. And 21 is 3 and 7. Though actually the only possibility to simplification something is the cup of 2, can represent 2, and stay inside the radical 21, que es 3 and 7 together. Okay, so this is one. Okay. This is the one possibility to express it using the irrational number, no? Entonces es negative 12 plus or minus 2 radical 21 divided by 6. Leave it like that, no? No, because I saw that 12, 2, and 6 is even number. You divide by 2, any coefficients, top and bottom, is negative 6 plus or minus 2 divided by 2 is 1, radical 21, divided by 3. Okay, this is the exact answer, but it's weird. Remember my goal is make a graphic. To do the graph, I need decimal approximation. I separate into this. Minus 6 plus radical 21 divided by 3, and minus 6 minus radical 21 divided by 3. And we compute in the calculator approximation. The answer is, for the positive is negative 0.47. And for the double negative is more negative, negative 3.53. Conclusion. We have two x and a set. Hey, professor, have been a problem? Okay. This situation happened. I understand. Entonces, negative 0.47, 0 is this point. And this point is negative 3.53, 0. And so in total, we have, how many points in total we have? Well, in total, we have vertex, 1 point, y-intercept, 2 points, and 2 x-intercept, 3 and 4 points. I can, using the symmetry, obtain the 5th point, the number 5 point, using the image of this guy. But okay, let's do it directly in decimals. I don't want to complicate more. This. Wait. The axis symmetry, the axis of symmetry is obvious. Okay, in this parabola is the vertical line. Symmetry, 3. Symmetry, no symmetric, no adjective. Symmetry. Symmetry is the line x equal h. H in our example negative. Good. And we're using that to create the image of that one. Que es, bueno, es obvio. Si es 0.5 and the image passes from 2, the distance is 2. And we have, bueno, I need to see graphic to understand this. Okay, let's go on to decimals. Do you see? You see, right? Do you see this one? Yes or no?
Yes.
Uh-huh. This is example 2. Look at that. Wow, fantastic. Look at that. Okay. The parabola open up because A is positive. Okay, this is the original problem. This is the original. Look. By the way, I copy here and another color. Look, they are okay. Look, they are perfect coincidence. I forgot to say this. Look, this is the original problem. Look, this is the original problem. The black color. Look, let me delete that, the parabola, and I put the original in black color. Okay. I plot the point. What point? When I plot the vertex, remember the vertex -2, -7. I plot the y-intercept is 0.5. Yeah, I plot both x in a set case, this weird number, -3.53, and -0.47, 0. Okay, so I obtain this point by the image using the symmetry property because the distance I know is 2. So distance, when you're talking about distance, it's positive, right? So the distance from the y-intercept and the axial symmetry is 2. 2 units, pero en opposite direction, 2 units, 4, so -4.5. Is the other point. This is using imagination, no formula. Common sense, guys, common sense, symmetry, image. Okay. And by the way, see you have in my hand H and K, H is -2, K is -7. I can write, and A is the same because A in the standard and vertex form is the same. A doesn't change. A 3, a positive 3. That is the reason that the parabola open up. Well, the formula in, look, the formula in vertex form, I transform like that. And you see that they are perfect equivalent. It's the same. Super? Okay. Let me take advantage. That moment, I have the graph. Nice. Supposed to answer some extra question. For example, domain and range of that function. What is the domain? Wow, the domain is, domain is in supposition, the domain, when the professor explained domain in the chapter 2 say, domain is all real number except the restrictions. But we have no restrictions. In the quadratic, never. We have restriction. Why not? Because we have no division by 0. We have no square root. It's just polynomial. It's a polynomial second degree. The quadratic equation is a polynomial second degree. Therefore, we have no restriction. Nice. It's super nice. And it's obvious that the domain is all real number. However, the range, no. Because the parabola opening up from the -7 point. That we have parabola from -7 to positive infinity. We have no parabola in -8, in -10, in -9, in -12. So the range is this region. Okay? From -7, so you, for example, want to express it in interval notation, you put bracket, important. Bracket because include touch, physically, touch, -7 to infinity. Clear or confusing? Let me come back to the whiteboard because I want to express this idea more clear. Okay, look at that. Okay. Whiteboard, do you see or no? Okay, suppose now to answer the question domain and range of this example, domain is all real number. Range, no. Range is from -7, of course, touch, bracket, comma infinity. Clear? Everything is clear in this example? Let me know. Clear or confused? Answer me. Do you see everything clear? Suppose que sí. Come on, okay. I don't see any in the chat, maybe. Clear or confusing? Come on. Answer me. So far. Yasmin.
Clear, sir.
Okay.
It's clear.
Okay. Okay. I bring another example. Another to illustrate another possibility. Okay, example 3. Example 3 now. Example 3 is, well, f of x is equal minus x squared plus 4x minus 5. And again, do the graph. It's our goal so far. Because you need to understand very well the graph of the quadratic function, and after we can see applications. Okay, now. Okay, question number 1 is, in what form is expressed? Standard or vertex? In what form is given? This in standard or in vertex? Help me, guys. Answer me. Vertex or standard?
Standard.
Standard, very well. Now you can see A is -1, B is +4, and C is -5. Okay, be careful with the sign, guys. Okay, -5. My next question is, in what direction is open that parabola?
Down.
Down. She said it's down because A is negative. I need to find the famous vertex, H, K. This is the most important point. So you cannot do the graph of the parabola without vertex. So you obtain y in z, x in z. This is complementary, but the most important point is the vertex. So the formula is H equal minus B over 2A. This is the most important formula today. Is. Why is important? It's important because in the vertex, look, in the application that you see after, now, you need to work problem in which you need to optimize the function. Suppose que the parabola open like that or open like that. So in that point, you see the maximum value, maximum. Entonces, suppose que this is about profit, something. Entonces now, si you want to optimize, you need to find the maximum, and the function is a quadratic function occur exactly in the vertex. But the vertex is super important point to optimization, maximization, maximize or minimize. Suppose see the parabola open up, it's the minimum value, right? Suppose the problem talking about the cost of production, something is given by the quadratic function. I need to optimize the cost. The cost is bad guy, it's the money I need to pay. Therefore, so you need to minimize the cost. You try to find the minimum in the parabola. Do you understand the idea? The optimization. So you see, well, this is complementary. This is only extra to illustrate the basic idea. Okay. Well, let's compute H. H in our specific example is minus big 4 divided by 2 times -1 because A is -1. Ooh, be careful. with the sign, we have double negative, right? It's positive. 4 divided by 2 is 2. H is 2. And what about K? Okay, it's easy. You evaluate the function in 2. Okay, it's minus, 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 minus. No X, no X. It's 2 squared, plug it in, plus 4 multiplication by 2, minus 5. This is negative 4, this is positive 8, and it's a negative 5. This is positive 4, minus 5, and negative 1. Okay, K is negative 1, K value. Therefore, the vertex of, is located at the point 2, negative 1. This is our famous vertex. Super good. Okay, complementary. Y and Z. Y and Z is super easy. It's C. It's the point 0, negative 5. No calculation, only looking at that. C is negative 5. Therefore, my Y and Z is located at the point 0, negative 5. 0 because it's on the Y axis. And X and Z is always very, very low, but a little bit complicated. You need to solve in this quadratic equation. Okay, let's do it by quadratic formula, I suppose. Okay, entonces minus b plus or minus square root b squared minus 4ac divided by 12. BF4, this is minus 4 plus or minus square root 4 squared minus 4 multiplication by a. A is negative 1 multiplication by C get negative 5. Divided by 2 times negative 1. Okay, as always, we focus in the expression inside the radical. That expression. Be careful, because we have a lot of negative. Wow, this is 16, it's obvious, you know? And we have 3 negative, 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 negative. 3 negative, negative. 20. Because 4 times 5 is 20, so it's negative 4. So now our expression discriminant negative. And that means when you try to find square root negative 4, it's plus or minus 2i. It's imaginary. Therefore, the interpretation of this is that our parabola have never crossed the x-axis, because the solution you find.
Yeah, it's a complex solution for the parabola.
Exactly. So the complex solution is not represented in our ordinary xy plane, because x and y is a real number. So the complex is located in another dimension that you don't see. Therefore, no, the conclusion is do not exist. This guy I tried to looking for do not exist. Okay? Do not exist. You see clear when you are doing the graphic, do not exist. Let's see how. Well, entonces, bueno, hoy, pero we have not too much information. We have only the vertex, boom. We have the y-intercept, boom, and no intercept. We lost point here. Okay, and what about axial symmetry? Axial symmetry is always useful. Somebody know how you block the robotic call? Okay, so axial symmetry is the vertical line, like that, boom, 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 passing through the point, the vertex, no? So it's x equal h, in our example, h is, boom, this is my axial symmetry. I take advantage. This axial symmetry to determine maybe some image, no? Suppose we have 0, -5, Here, 0.-5, 0.-5. Well, that's weird. Let me try to understand when they're doing the graph. Let's go to Desmos again. In Desmos, we have okay, boom. There you go. It's example 3. Example 3. Look. Example 3. Do you see Desmos? Yes or no? Answer me.
Yes.
Okay, super. Nicole said yes. Thank you, Nicole. Thank you, Yasmin. Well. This is the original equation. Look. And the most important point is the vertex. Okay, I found 2.-1. And I determined the y-intercept is 0.-5. And using the axis of symmetry, I determined the image of this point is 4.-5. Why 4? Because the distance between the axis of symmetry and the y-intercept is 2. So you look at that. And 2 plus 2 is 4, because it's the same distance. Unfortunately, we have no 5 points. We have 3 points. But okay, I know complementary que hago parábola up and down. And that's it. And that's it. Oh, I forgot to say something important. You see now, clear like a word, que agua parábola never crosses the x-axis. That is a reason, this is explanation why when you try to do your best, compute the quadratic formula, the answer is imaginary or complex. Because this parabola never crosses the x-axis. Super clear? Or confusing? Okay, let me share again now the whiteboard. Okay, boom, boom. Do you see the whiteboard? Okay, let me erase the whiteboard. Okay, let's move on to application. Wow, I don't like this. Application. Okay. To erase the last part by using this tool. Okay. Application now. Application. Suppose in a test you see word problem with the application. And the word problem is easy. It's always the same. Suppose the first example of the problem number 1. Talking about the profit. The profit that the vendors make per day by selling X items, not a specification, what the product is vendor selling. Is given by f of x is equal negative 0.002 x squared plus 1.6 x minus 200. Okay, this is the formula. Investigate the plot and make the quadratic regression. The quadratic regression is a, it's approximation. You find the equation for the point. And the she data that you collect in the real life. So find the number of items that maximize profit. Entonces, the equation for the profit is a quadratic function. Let me rewrite again. Minus 0.002x squared plus 1.6x minus 200. This equation represents quadratic function. How do you know? Because the clue to see that is this exponent, quadratic. Si this exponent is missing, entonces es linear, maybe, ¿no? Pero en this case es quadratic. Es separable. Es obvio que es separable. Entonces, this equation es expressed en estándar o en vertex form. ¿En estándar o en vertex form? Es important identification. Estándar o vertex. Answer me. Standard or vertex?
Standard.
No, standard. Si es standard, you can identify super easy ABC. Es obvio que A. Who is A? Who is A?
Negative 0.002.
Exactly. Who would be?
1.6.
And what about C?
Negative 200.
Very well, because you need to keep in mind the signs. It's important, the information for the sign. Okay, so the problem talking about maximize profit. This quadratic function represents parabola. Okay. And this parabola open, in what direction open this parabola? In what direction? Down. Down. The reason they open down is because A is negative.
Yeah.
Okay? This is the reason. Entonces, exactly the maximum, okay, want to find occur in the vertex. Okay, H comma K is the vertex. So one more time, in order to optimize my problem, I find the vertex. H is equal minus B over 2A. Remember, the most important formula today is this. Okay, so now, plugging in, minus B is 1.6. Multiplication 2 times A is negative 0.002. Be careful, we have double negative. Negative of the formula and negative of the A. And make sense because H negative have no sense in the word problem because who is H? H represents X value and X value is the items que this guy is selling. Entonces, you put in a calculator, 1.6 divided by 2 times 0.002. And of course, double negative, the answer is positive. 400.
Yeah, the answer is positive 400.
Positive 400. Okay, and that's it. Because in the word problem, he wants to know only the number of items. Okay, selling 400 items. There are another kind of problem, but know this. In the test, you have 2 word problems similar to this. Super easy. And the first one, you find only the H component. Okay, represent in this word problem the items selling. However, you can find the profit. Yeah, you can find plugging in 400 into the formula and you get the dollar, get the profit. But no, I don't want to do because in the another problem I have here for you, it's completely different. You find the money, not the items. Any questions so far? No? No problema. Super clear or super confused?
It's super clear.
Super clear. I have another problem. Can bring me new situation. Okay. Problem 2. Application. And the problem 2 is about the owner of video store determine that the cost function is represent like that. C of x is a cost, capital C cost. 2x squared minus 32x plus 630. Okay, where x is the video, rented daily. Now I need to find. The lowest cost to the near dollar. Okay, to the near dollar. Okay, so now I copy again the function. C of x is equal to x squared minus 32 x plus 630. Again, we are facing quadratic function. This quadratic function is expressed in standard, it's obvious, right?
Standard.
Standard. Entonces, who help me to determine A, B, C?
A is 2. B is negative 32. C is 630.
Exactly. My next question, this parabola in what direction open?
The parabola opens upwards because A is positive.
Very, very well. The parabola open over because ya me say que the A is positive. A is equal to a positive. Entonces now, they are probably talking about minimization. So lowest cost. I need to find when the function is minimum. So the minimum occur in the vertex again. Now the vertex have two components, no? H and K. H represent video because where X, this is a point. This is X comma Y. The H, you know, is a letter that we are using to denote the X component of the vertex. And K is the letter that we use to call the variable que is the Y component of the vertex. In our word problem, X is videos. How many videos? I don't know. I need to find that. And K represents the cost in dollar. So the final goal is K. Okay, find the K. Let's do it. Again, I copy my famous formula, H is equal minus B over 2A. A minus B, can be negative 32. Be careful with the signs. 2 times A get 2. So we have double negative.
H is negative 8.
Negative A or positive A?
Negative.
No, look, I mean, the formula have a minus. However, B is negative. Because we have double negative. Look, this negative and this negative. Together is positive. And I'm so happy that this situation happened. Because negative a video have no sense for me, pero positive yes. Do you understand this or no? Yes or no? Clear or not clear? And this is the answer. No. This is not the answer. The answer is the money. Okay, you need to expend in order to offer to the public the video. Entonces, sí, evalúen. Entonces, 2a square minus 32 times a plus 630. Okay, using calculator, of course. Let me try using my calculator. In my calculator, I put 2x squared minus 32 x plus 630. Yeah, I plug it in x equal 8 video. Boom, I get the answer. The answer is $502. And this is the answer I want. Oh, they want. Find the lowest cost. This is the minimum cost. When you rent a video. So you rent it more than 8, the cost increasing. Of course, the profit increasing, no? But the cost increasing. So you rent it less than 8, so you are in big trouble, no? Because the cost is bigger. It's bigger, no? And the profit is not bigger, it's smaller, I suppose, using the common sense. Okay, super clear. At least for me, it's clear. And for you, it's clear or no? Totally confusing. But I try to illustrate this in the review package. I promise. If we see more examples of the word problem. No, don't be scared for the word problem because it's easy. It's nothing. Okay, we have time to start. New section. Okay, I repeat again, guys. Remember, today is the due date to send me by email the answer of the test number 2. And don't forget to submit the test online in Alex number 2. And remember, okay, I forgot to say something. Listen to me, important. I need more subscription in my YouTube channel. If you subscribe today, or today, no, from today, in my YouTube channel, I give you 5 extra points in the test 2, and the test 3, and the test 4. 5 extra for the subscription, okay? It's important when you subscribe, I need to see the notification, no? The YouTube channel, send me a message on your name. Okay, do you like that? This idea is good or no? No? What do you say? A subscribe, you know, it's super easy. Sound good, dice Diego. Subscribe is super easy, no? You click in the red button. The only thing you have to do, everyone's supposed to have a Gmail account with the Google and the Gmail. They ask the Gmail and that's it. You want in one moment, if you don't want, you delete the subscription, no? But to take it with me, the class, if you are subscribing my YouTube channel, I increasing 5 points in the test 2, and the test 3, and the test 4. Okay, it's 5 plus 5 plus 5, no? 15 points extra. Take advantage. Okay, next topic I want to start because we have time. It's a rational function. Rational function is a little bit more complicated. a little bit. What definition? First, definition. Definition. A rational function is a function que we obtain when you divide by two polynomials, P, Q. Who is P and who is Q? P and Q are polynomial. Polynomial function. Polynomial function. When the test, okay, what do you say? The test today. Es tú, ¿no? Ahora, let me see in the chat with your question. Chat. Okay. You ask me something or when the test on paper is due? Today. I will grade tomorrow. So you have the entire day today to send me the test. Okay? Clear? Polynomial function. But. Important to say something. Suppose that Q never is 0. You know that. Because division by 0 is undefined. Okay. Let's see several examples to illustrate the, the possibility of the rational function. Example 1. Example 1 is f of x is equal 1 over x. This is elementary. 1 is a polynomial, yes, degree 0. No x, degree 0. And x is a polynomial, yes, degree 1. So now, one super important thing when you face the first time rational function is the factory form. What means that? The factory form is your factorization. You try to do your best. Factorization, the top polynomial P, factorization P, and factorization Q. It's super important. It's the first step that you should do in any analysis of the rational function. Factorization at the top, factorization at the bottom. Well, in this elementary example, because it's the first one, it's impossible to do anything. The factory form is exactly coincident with the original is given. So it says 1 over x. And domain. Domain is, well, the only restriction I can see is when the denominator is 0. Therefore, domain is all real number except 0. The bad guy is 0. It's the restriction. That's it. End of story. Do you understand this? But I want to, explain one more thing. One more thing is confusing a little bit, at least for me. Look, suppose the graph of that function. Are you familiar because you see before when we study the family of the function in color algebra? It's a reciprocal function. A reciprocal function looks like that. And this function is undefined in 0, and the reason it's undefined is because the curve approaches but never touch the y-axis. That is one line is called, you need to be familiar with this name, vertical asymptote. Okay, vertical asymptote is a hypothetical line, vertical, no? Que the curve, que is a red color, approach but never touch. And never touch because it's completely out of the domain. It's like one branch of the function go to the positive infinity and another branch to the left go to the negative infinity. Now the curve in this direction increasing forever to the positive infinity, here decreasing forever to the negative infinity. We have one more thing. Is another line horizontal que happen similar, no equal situation, que es a horizontal ascent. In this case, it's like an end behavior. What means end behavior? Well, end behavior means that when the x approaches to infinity, look, infinity positive, the curve approaches but never touch the curve. Likewise, no, in this case, I make a mistake, no? Never touch. And likewise, when the x approaches to the negative infinity, que es in another direction, the curve again approaches but never touch. And this is called horizontal. Keep in mind, because you you hear in this topic 1,000 times talking about vertical axis and horizontal, and you need to discover and you need to understand this. Okay, that was example 1, super easy, elementary, kindergarten example. Let's move on to example 2. Example 2 is a little bit more interesting. Example 2 is the function I need to change the name is g. It's rational, like any rational x division to polynomial. Suppose phi x is a monomial in the top, and this is a binomial in the bottom. Trinomial, sorry, x squared minus ax plus 12. Okay, super. Super. Now, we have the factor 4. That's the first thing you should do. Well, the factor 4 is do the factorization. Well, it's possible. Sometimes it's impossible. This is a monomial. It's impossible to do anything. But this is trinomial. Yeah, we can. Factorization. The combination is 6 and 2. Because 6 times 2 is 12. And 6 plus 2 is 8. Negative. Boom. Perfect. This is the factor 4. What about domain? Well, domain is, remember, when the q of x is equal to 0. But no 0. This is domain. This is restriction. And our example is x minus 6, no 0, and x minus 2, no 0. Conclusion, x no 6, and x no 2. This is a bad guy. When you plug in that value, the answer of this function is to be undefined. So g evaluating 6 and g evaluating 2, both is undefined. Completely out the domain. And the reason it's undefined is because I suppose, I don't want to explain clear now, because we have two vertical axes. Okay, suppose this is the axis. 1, 2, 3, 4, 5, 6. We have 2 vertical axes like that. I have no idea exactly how. This is not the point now. Today, no. Today is not the day to understand very well. We have vertical axis to 1 and vertical axis to 2. And the rest in between, I have no idea. It's not important now. The important now is you understand factor 4, you understand domain, and this bad guy represents vertical axis. Oh, bad guy, vertical axis. Horizontal, no. Horizontal is good guy. We respect the idea for the domain. Okay. One more example. Example 3. Example 3 bring me a new situation. Is h of x is equal x plus 3 over x squared plus 4. Wow. Okay, let me try to understand this. Factor 4. Well, factorization. The top is impossible. This is just a binomial, but it's prime expression. And the bottom is also prime because I remember something. Look at that. I remember in intermediate algebra classes that the famous difference of a square, the factorization is a plus b times a minus b. And the sum of a square, the professors say it's impossible, the factorization, and they call prime expression. Wow, leave it like that. And the reason, look, the reason is prime, to understand more clear because you are advanced students, is because here I try to solve this quadratic equation. Look, take that. Well, it's by square root method. I move forward to the other side. You apply square root both sides. X is equal plus or minus. Why? It's imaginary. There is a reason. That the reason it's impossible factorization is because the number involved inside this are imaginary complex. Then the real field, is the field that we are working in intermediate algebra at the beginning, is obvious that it's impossible to have the factorization. So now, conclusion, the idea, so the idea que es division by 0 is impossible because the number that satisfies this equation is imaginary. Therefore, the domain of that function is all real number. Let me repeat that again. Remember, the idea behind domain is always the same. You assume that the domain is all real number except the restrictions. And the restriction in this case is when the denominator is equal to 0. And I discovered that when I enforce the equation and the polynomial in the bottom equal to 0, the answer is imaginary. Therefore, in the real field do not exist the restriction. Therefore, the domain is all real. And basically, we have no vertical acid in this curve. Okay, you need to be aware because in the test, I want to emphasize too much this idea they exist or do not exist the vertical acid. And this is easy. When you try to find the polynomial in the denominator and you enforce it to be 0 and the answer is complex or imaginary, it's because we have no vertical acid. Okay? Well, 5 minutes, last example. This is just introduction. We start studying in detail this topic next time. Okay, example 4 gets very, 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 very interesting and bring me new situation. Example 4. Example 4 is a polynomial function p, no polynomial, sino rational p, que es x squared minus 5x plus 6 divided by x squared minus 7x plus 1. Okay, this is given, and the test is rational, polynomial, degree 2, by the way, degree 2, is the degree of the polynomial at the top, and degree 2 is also the polynomial at the bottom. It's a coincidence, and let's see what happens with this coincidence, but not today. Okay, now factor 4. Well, factorization. 2 trinomials, 1, 2, 3, and 4 parentheses. The factorization on the top is easy. It's 3 and 2 because 3 times 2 is 6 and 3 plus 2 is 5 minus both. The factorization at the bottom is easy also because of 4 and 3. Because 4 times 3 is 12 and 4 plus 3 is 7. Negative of. Wow. And this is the new situation. Look. This 3 is cancelled out. Chum, chum. And this is equivalent to say x minus 2 divided by x minus 4. Let me explain in detail this idea, because it's a little bit complicated to understand. Okay. Suppose now I want to compute domain. Suppose I want to compute domain. Domain is all real number and except the restriction. How many restrictions we have? We have 2 restrictions because this is a restriction and this is also a restriction. So x no 4 and x no 3. And you say, Professor, but 3 is cancelled out. Okay, be careful, be careful. That means that at x equal 4, we have very cost for sure. But in 3, no very cost. We have another new thing is called whole. And the representation for the whole look like that. When you are doing the graph, you are doing the whole here. And in the specific point, you are doing the whole. Sorry. Whole is the representation is like that. Whole where? Entry. Okay? Entonces now, well, the question that fly in the air is, well, Professor, and this expression are equivalent? The answer is yes, except que you suppose que x is not 3. And this is the reason that this is a whole. But this statement, compound statement, you say is 100% equivalent to the original. It's 100% to the original, under the consideration of the 3. And the practical analysis, you know that fact. You know in 3 we have a whole. So when you are doing the graph, you put a whole like that. And you continue working with this, because the lowest term simplified way to express this is complicated. But keep in mind that this statement is valid, this equivalence is valid if you ignore 3, because you know default in 3 we have a whole. Okay, this is. Let's see. I promise that next time we see a lot of examples. Sometimes include a whole. How do you know that we have a whole? Well, you know that we have a whole when the one factor is cancelled out. So then, in the analysis of the rational function, the first step is factor 4. See, we have no common factor to cancel out. That means that we have no whole. See, one factor is cancelled out. This is a whole. Okay? And the whole is no very cost. It's another graphic representation. Super good. Super cool. Okay, the time is over. We gotta go. We gotta go. So remember, I recall again, please submit today the test number 2 online and send me by email. A lot of people send me already. Okay, by email the answer of the test number 2 on paper. Thank you so much for your attention.
All right.
Thank you.
See you next Monday.
Absolutely, yes.